Green Marlborough. My name's Jennifer Boudry. Today we have John Walker from the Jordan Institute. Welcome to the show, John.
Thank you.
Thank you for coming. We're going to talk today about LEED, L-E-E-D, Leadership in Energy and Environmental Design. Do you have a background in?
CPA at one time, owned a couple of my own companies, was the chief financial officer of Earthwatch, which is located in Maynard. And that's really got my interest in science and in the energy field, because some of our projects involved energy issues. And while I was still there, we built a townhouse in Hudson that is not to LEED standards, but pretty energy efficient. I think of the first January I was there, my gas bill was $35.
Wow.
And so that included the stove and hot water. So
that's amazing.
We're
going to get into that in a little bit, but right now you're also at the Jordan Institute.
Yes, I'm a consultant for Jordan Institute. Jordan Institute is a nonprofit based in Concord, New Hampshire. Their mission is building climate change solutions. It's a very small nonprofit, but we have several different activities. One is advocacy. We work with the legislature on energy policy. We have a program which we call GSE2, Granite State Energy and Efficiency. And that's working with municipalities primarily, but some commercial, on evaluating schools, municipal buildings. Then after the evaluation, if they so choose, implement the changes. Then we also do consulting for LEED projects, either large buildings and homes.
And these could be new construction or retrofit?
It could be all of the above.
Renovation, okay.
The homes are generally new, because LEED for homes is very recent. There are several, and we have some slides, but there are several different versions of LEED for commercial and industrial buildings. And so we consult on those projects, and it can be retrofits or new, and in homes, in all cases, it's new.
Let's start by talking about some of the information that you brought with you, which is why we need to have LEED construction.
Yes, sure. And LEED, as we said, LEED, and I should emphasize this energy and environmental. And so a lot of the LEED work is surrounds the environmental part as well as the energy. And LEED changes from year to year as well. And so we understand the new LEED will have a little bit more emphasis on energy.
One of the reasons for doing that is the energy consumption that we have in the United States.
This is the entire U.S., and it talks about both industrial at 32%, transportation 28%, commercial 18%, and residential 22% of energy consumptions. And if we look at the infrastructure, buildings account for 48% of all the energy use.
So 48% of the energy use in the United States goes to buildings, our homes and our businesses.
Yes, and it's even higher. That's for the entire U.S. In New Hampshire, it's 59%. And that's weather related. In Massachusetts, I don't know the number, but it's going to be higher than 48 and less than 59. So that it's a significant factor, and it is significantly more than both transportation and industrial. So that we've selected buildings to work on because it is the largest, and in terms of conservation and global climate change, it's much easier to save energy than it is to produce new alternative sources of energy.
Exactly.
And with 59% of the greenhouse emissions in New Hampshire, why not save it?
Right. Build an energy efficient building just from the get-go. You'll save
and
a lot.
Retrofit. I mean, most of what we do are the retrofits.
Which means going into a building and weatherizing it, providing insulation, appliances that use less energy. So all those things that make
generally find air sealing is number one. And
sealing the air in the walls and the ceilings.
And especially in schools, there are all sorts of air leaks that can occur that people, and they're hidden a lot of times. And so we go through the same process you would in a home. We do an audit, or we call it an assessment. We use blower doors, sometimes 5 at a time,
So you'll go into a school then, for example, and you put a blower door on each door just to test where the leaks are in the building.
Yep.
Yep.
And then we'll do an infrared, and there's some new things, video infrared, where you actually can see the air coming in.
How interesting.
And it's great. Part of what you have to do with the assessments, as opposed to a homeowner, you've got school committees, you've got town councils, you've got to convince people. And so the video is a much more effective presentation tool.
Interesting. The technology
it's
for
great.
analysis is amazing. So right now in New Hampshire, you've got, well, actually let's talk about the buildings and transportation. This slide shows the buildings consume more energy.
Well, it's interesting because industry is relatively flat-lined relative to both transportation and buildings. And industry is much more attuned to the economics of energy, and so they have responded better to it. They've made this, energy is critical to the processing of their products. The EPA has something called a software program that we use to rate the relative energy efficiency of the buildings we evaluate. And Energy Star, which is another rating system.
From 0 to 100, 75 is or above
exactly.
is Energy Star.
Right, exactly. That's our first step, is to evaluate the building and see where it stands. And if we look at this graph, the bar graph, the oldest building in our study, built in 1953, managed a score of 5. And
that's low.
The best was a middle school built in 1989, which reached 72. But if you look at partway down the graph, from 90 elementary schools, series of elementary schools built in 1997 through 1999 are very poor ratings, 5, 20, 10, 13, 9, and 15. And these are schools built in the 90s. These are not old schools. And so what we've been finding is some of the newer schools, which should have better ratings, don't. And of course, then you would preach to the school committee and say, you know, the building you just built doesn't do very well. And so that creates more of a political issue. The bottom line graph is an interesting one. SPNHF is a Society for the Preservation of New Hampshire Forests, which is a LEED gold building.
Probably new.
Well, it was an addition, the LEED part of it. And that rated a 99 on the scale.
I'm sure that during the study you were surprised, you know, to see that the newer, it doesn't matter if they're new or old, some of them are not energy efficient, and all of them can find ways to make themselves more energy efficient.
We haven't found any that we couldn't do something with.
And simply the payback on making some of these municipal buildings more energy efficient is high.
It is. Yeah, we guess that we can generally, a project of a buildings rated as low as these, we can save upwards of 50% of their energy. And part of my role is to build the economic model to provide the internal rates of return, and which is a sophisticated way of saying payback.
Exactly.
And
so, for example, if you invest this amount of money to make the building more energy efficient, it will take you this long to pay off that investment. And sometimes it can be a very short amount of time. It could be months, it could be years. It's not very much for some really basically simple changes, and the payback is extraordinary.
Absolutely.
I mean, simple lighting and simple weatherizing.
And the ceiling. And the school committees sometimes look at individuals, sometimes they look at it as a package. And the other thing that we build into the model is an inflation rate for energy. Lots of times people say, gee, the payback today is 10 years maybe, and I say, well, that's so-so rate of return, but if you build in a 10% per year inflation rate for energy, and we feel that will be conservative. Now, we've seen energy prices go down, but they're going to go like this, and we're basically at the limit for energy, oil, for example. And so we can look at paybacks that were 10 on today's prices, maybe only 6, assuming a 10% inflation rate.
And retrofitting the school buildings or municipal buildings or government buildings, you know, buildings that are going to be used year after year after year, you know, the same function is a definite payback over time for the community. Businesses and